I'm Chip. I'm from San Francisco. So this is my second time at this conference, and I absolutely love it. So like when Mark asked me to be here, I was like at my favorite city, with my favorite people, then like why not? So out of curiosity, like who here is from Atlanta? Woo! So who here has moved here from the Bay? Okay, we have a few. I think it's like people keep telling me that I need to move here because you have the best chicken sandwich. So I need to do that. I've been trying for lunch. Cool. So today I'm going to be talking about. Wait, I need a clicker as well. Thank you. I feel like a guinea pig with this conference now. Cool. So today I'm going to talk about engineering anti-patterns. So before I was working for a while at like NVIDIA and a couple of startups, and then now I'm working on like AI for education and entertainment. So basically for storytelling. I was telling Cody just before this event is that I do believe that as AI automate more and more. Okay, that sounds quite scary. Like people keep telling me I shouldn't say this out loud. But I do think that like there are a lot of like tasks that AI can do. And there's one thing that I do think that like will never go away, which is like a people desire to be entertained. So I do think, so I'm got very excited in like working with like AI for like creative field, for example, like for gaming, books, movies, and especially for like content adaptations. Like if you have a good story, right, you can convert that into a video or like a board game. So that's what I'm working on. I also believe that if we can use AI to create intellectually stimulating content, like we cannot just like be entertained, but we can also like learn something new through the process of doing that. Okay, so let's go back to the talk. So it's going to be not very long talk because we don't have a lot of time. And also I know that like this conference, I don't know, whenever I come here, I feel like people are very smart and very engaged. So I made the talk a little bit more interactive. So like feel free to like raise your hand. I'm gonna have a few questions. So if you need a question, like do so. So today, when I talk about like two main topics, first is like, because I wrote a book on engineering, a question people always ask me is that like, how is that different from machine learning engineering? Are you just making up a new phrase to sell books? The answer is no. And also we'll talk about some of the few anti-patterns I have seen. Yeah, so I think Mark Khalifa already mentions, like we have a book giveaway. Cool. So who here has these questions? Like how is AI engineering different from machine learning engineering? Okay, a few people have these questions. Yeah, so like machine learning engineering is a process of like building machine learning applications with traditional machine learning model. For example, like spam detections, fraud detections, or recommender system. Whereas engineering is a process of building applications with like foundation model. And people use the term foundation models as a superset of like including large language model, because the vast majority of models nowadays are not just language anymore. So I think everything nowadays is like multimodal, and I'm very excited about a lot of like image and text to image, or like text to videos, or like text to audio podcasts. Like it's really, really amazing. So example like code generations, customer support chatbot, or like personal assistant. So it's a very quick overview. So with the traditional machine learning engineer process, right? Like before, you start with like data. Like if you want to think, okay, I have this idea and I want to use AI like to make decisions. You first start by collecting a lot of data. And then with the data, you like train a model. And then with that model, now you deploy that as a product, right? And then with AI engineering, the process is different. Like usually people like, okay, I have this really cool idea. Let's just prototype something really, really quickly. And then, okay, now it works really well. Let's try to get more data and improve that. And then when it worked really, really well, it's like, okay, now I don't want to pay a lot of money to this like OpenAI or Anthropic or Google. Maybe, I don't know, we have a bunch of speakers from Google today, so maybe you should pay Google. Or you can say, okay, let's try to like fine-tune the model to fit your need better. So the process is like kind of like reverse. So what does it mean? I think it's a little bit of like man-formatted because it converted from like Google Slides to this. But like with AI engineering, because the models themselves like are quite commoditized. Like a lot of people use the same models. So the competitive advantage is now lie in like product and data. And I think we see like quite a bit of change in organizational structure, right? Like we see this like before, I used to see a lot of companies had a very distinct, like between the engineering team, machine engineering team, and the product team, and like the different people which like curate and like wrangle data. But nowadays, I see that like people like with product and data and ML engineering people are like very close to each other. And usually a lot of time, like these teams have to work very, very closely because you have to start from product. Who here is a product manager? Nice. I really think it's really, really great to have like good product sense because that's how you stand out in this extremely competitive market, AI market. So again, just a few summaries of like the difference between engineering and ML engineering. So with machine learning engineering, you usually have to build your own machine learning models. And with engineering, you use like some existing AI models. With ML engineering, in the past, machine learning applications were typically deployed as part of existing product. For example, fraud detections could be deployed as part of like a banking app. If you build a recommender system, you could deploy it as part of like an e-commerce website. For example, Home Depot. I actually found out that like Home Depot is one of the like top e-commerce website in the U.S. So like they have a very good recommender system, like also like Amazon and like other e-commerce website. However, with engineering, right, you don't need an existing product. Like you can deploy these applications as standalone applications. And I've seen a really, really exciting trend recently. Did anyone here see the article by like Sam Altman saying that's the rise of like a $1 billion company? Yeah, so I do think that's a new trend that I've seen. That's like some like very motivated, smart engineers, or like not engineer, but someone who like have really great ideas, can build something really quickly and launch. Like with a subscription service, like I have a few friends who just like build an app over a few weeks, and like they make like hundreds of thousands of dollars like monthly through subscriptions. So I think that's just very, very exciting. And another change is that like before, because you had to build your own model, you need a lot of machine learning expertise, right? You need to understand like gradient descent, you need to understand a learning rate, you need to be able to look at the overfitting, underfitting curve. But however, like with engineering, you actually don't need to know a lot of that. I'm not saying that like knowing those concepts like won't help you. I do think that's a lot of value to understand like this machine learning concept because it helps you understand how models work under the hood, but it's not the prerequisite to start. Like you can actually like start something small without like prior knowledge and then learn as you go. So usually I ask people like, who here can explain what gradient descent is? So? Okay. Because like I feel like whenever I ask this, like so I sometimes I go to like give talk as like companies, and whenever I ask this question, like everyone just look at each other. It's like, am I gonna get fired if I don't raise my hand? So no. So yeah. So I have like I know some wonderful like engineers who actually cannot or like don't get very excited about the mathematical concept behind it. But I do encourage people like if you use something right, maybe you don't like if you use a microwave, you don't need to understand like how a microwave works. But it's important to understand the high level, right? For example, like I shouldn't put like plastic or like foil in microwave. So it's good to understand how it works at a high level so that you don't make mistakes that can like be very costly. And I think like a very important thing is that I think people usually ask me is like, so like, should I become an ML engineer or like AI engineer? I think the question here is or. It's typically and. Like in the vast majority of systems I have seen, it's not just machine learning engineering or like AI foundation models, but like maybe like I have asked like at multiple companies, right? And I think the numbers using like about like 50 to like 80%, even like 90% of AI applications that like combine both traditional machine learning models and foundation models component. So here's an example of that. Anyone here building a chatbot? Customer support chatbot? Okay, no one raises their hand. I feel really hands. I feel like people are lying. It's not possible. Okay, so let's say you've been a customer support chatbot, right? And here, maybe you have received a query from customer. And maybe you have different ways to respond to request. Maybe at first you have to classify whether it is a request that your AI model should respond to. So for example, if you have a company that sells software, and users say tell me a dumb joke about Trump, right? Apparently you don't want the bot to engage with that. So you might want to have a classifier okay, is this appropriate? Should I even respond, or should I just sorry, we cannot talk about anything beyond this topic? And then maybe you can have a classifier okay, is this question easy? Maybe you ask how to change my password, right? Then maybe you can okay, let's just send the users one of those FAQ. You don't need to engage with that. But then if the question is something really, really tricky, why did you charge me twice last month, on billing? So you might need an actual human operator to engage. And then if the question is maybe other than that, you can send it to an AI model or an expensive one or a smaller one. So you have this router here to classify the intent and the optimal route of the request to answer the request. And then after, let's say you have the AI model to generate a response, you might want to double check does it contain some PAI information? So a lot of system, if you retrieve information from the database, there is a chance that it might retrieve personal information, not just about this customer, but about other customers. We don't have time to get into this right now, but I do think there's a lot of interesting patterns that can accidentally reveal users' information, especially in cache system. For example, you can cache user A question. So user A asks what is my account balance right now, right? So if you look at the questions what is my account balance, and if you cache the answer to these questions, and the next time somebody asks what is my account balance, you might retrieve that answer previously generated for the other users, and that can reveal PII. So you might want to double check, here, is this safe to send back? Is the AI generated question also be damaging to the brand? Maybe the users, maybe you work for Home Depot and the answer question asks where's the best place to buy this stuff, and AI answer Amazon. So you probably don't want that kind of answer. So you might want to have another scorer or PII detection to check your answer. So the component the router and the scorer, the guardrail at the end, are typically traditional machine learning models that you build in-house. So a lot of the systems, you actually don't just have foundation model, generated responses, but you also have a lot of other components that you build in-house to make the systems more robust and more useful to the users. And of course, you make more money. So are we clear for now? Wow, I feel are you? I can't tell if I'm being really clear and understandable, or people are just really sleepy. Okay, so I do think that AI has become part of software engineering toolkit. So I do think it's because it has become a tool that everyone can use. It's just the way that JavaScript and databases are. It's just part of the applications. You build it, everything okay, do I need a database? Do you need AI? So I think it's very exciting. I think I made this meme. Let's see. How do I open this? Yeah, I do think it's AI engineering. I think of it as a superset of machine learning engineering. And then they own eventually, I believe that it's become part of the full stack engineering. I do see that the gap between engineering and full stack engineering is becoming increasingly smaller. I was talking to a bunch of my friends who are hiring for engineering, and I asked them okay, what are some top 3 skill sets you're looking for? And a lot of them said web dev. And I was interesting, because they need people who can prototype quickly and test things out quickly. So it's become very interesting shift. Okay, so now we go to the next one, engineering anti-patterns. So this is more interactive. So I hope that you have enough coffee so that we can have a nice discussion here. Okay, so the number 1 anti-pattern I have seen is that people use generative AI when they don't need generative AI. So this is an actual pitch that I got from a startup team. And they came to me and say, hey, we have this wonderful applications. that's gonna help you optimize energy consumptions, right? So the idea is that like you get the users to tell the app like how they typically like what activities at home that consume a lot of electricity, and then the AI is gonna like send back recommendations on how to reduce your electricity consumptions. And they said that like with the cohort initial users, they found that they can reduce the electricity bill by like 30%. And they said like, it's free money, right? Why wouldn't anyone want this? So what is the problem here? Would you invest? No? Why not? Everyone knows the basic? That is true. So you think it's more user behavior rather than knowledge. Like people like get like lazy, right, and don't want to do that. Yeah. So actually, one like yes, user behavior. Like if the AI tell me like, hey, you should do the laundry at 3 a.m. in the morning, like I'm not gonna do it, right? But also like another thing is just like I did actually ask them like, so what if I just tell the user do it a very a greedy algorithm, right? What if I just like schedule the most electricity consuming activities at the cheaper hours? Like if I know that's like electricity after 9 p.m. is it's cheaper, then I should just like do laundry like after like 9 p.m. right? Or like if I know this, or I can charge my car overnight, right? Like how much could that like reduce the electricity bill? And they were like, I'm not entirely sure. And they said they would try it and get back to me, and they never did. But then they pivoted. So hopefully, so I think a lot of like optimization tasks like that, there are a lot of tools to do it, like algorithm, like convex optimizations. That's very straightforward and a lot faster, and a lot cheaper, and a lot more effective. So you don't need generative AI for these cases. So I do think it's like, for a lot of companies, especially in the early day of generative AI, like just want to use generative AI so they can have a headline, hey, we are using generative AI, right? So they don't actually care about the outcome. I think like if it's that, like if you want to use that for marketing, that's totally fine. But like the headline of like we solved the problem is very different from like the headline of like we use generative AI. So it really depends on what you're aiming for. So I think I tend to tell people like we should be more solutions. We should be more like problem oriented instead of like technique oriented, like keyword oriented. Like just focus on whatever the cheapest and easiest way to solve the problem instead of trying like the hardest new technology. Okay, so another thing, so the second anti-pattern is that like you confuse bad product with bad AI. So this is from my friend who works for pretty popular applications that summarize, they look at some meeting transcript and then try to summarize, it's like what would users, like summarize the meetings to users, right? And in the beginning, one of the things they really care about is like how long could the transcript be? Like, and for example, they agonize over like, would people want a shorter summary, like 3 sentences, or like something longer, like 5 sentences? So who here thinks that user would prefer 3-sentence long summary? A few? Okay. Who here thinks that user would prefer 5-sentence long summary? Okay. Cool. It's a trick question. So they actually find out that users actually don't even care about the summaries. What users actually care about is like, what do I have to do next? So like they care about the action item after the meeting, like, okay, what do I need to pay attention to? Because most of the time, like the summaries are actually quite similar. Like A said this, B said A is an idiot, or something like that. Yeah, so it's actually not super useful. So here's an example. So here's another example, right? This is actually a pretty popular example. So I'm not sure if you have seen this before. So LinkedIn had a bot to like help users assess whether it's a good fit for a job, right? And expectation is that like, okay, we not just have users answer very correctly. And that's the expectations. What do you think the reality is like? What do you think users actually want? Jobs? Yeah, no, good answer. I love that. Yeah, so like at first they optimize like to have the bot answer as accurately as possible, right? And then they have a situation like this. Candidate could ask like, so yeah, like if the boss is saying no, you're a terrible fit for this job, it's just not a very, very good, very helpful. So like they realize it's like what they want is that like to help user like them identify the gap. Like, okay, is this looking for this skill? But because you don't have it yet. So here are the things that you can do to improve your skill set. Or like you might consider alternate like other jobs that might be a better fit for you at the moment. So it's very important to understand what users want. Here another example. So here's a tax season. Who here is still doing taxes? I wake up this morning with my accountant yelling at me like, tomorrow's the deadline, haven't sent me documents. It's like, oh my God, I'm gonna go home and do that immediately. So here's a tax website, right? Originally, they want to deploy an app to like a chatbot to help users answer like tax questions. But then they realized it's like very few users actually use it. So what is the problem? What do you think? Why do you think? Okay. Low confidence in the bot? Yes, so like you're worried about hallucinations. That's a very, very valid concern. Any other reasons that you might think? Yeah. Sorry? Very generic. Like the answer very generic. That is also like very, so the quality of the answers is bad.
People don't want to expose their personal information.
I literally spend my entire life to the tax applications. I feel like they know how much money I make, like what I'm spending money on. I feel like, yeah, so but it's a valid, I feel like, so like trust on the applications could be like very important. System? Oh, seasonal. Okay, so like people care more about like April. I feel like January to like April is like everyone is like fixed system. Yeah.
I don't want to ask questions. I just want it to do my taxes and do it right.
Yes. No, I think that's a very good point. So they found out two things. First is that like users don't know what to ask. So they're using a tax application because like, most people don't understand this, like they don't even know where to start because like all of those are like so confusing, right? And the second, they found out that people hate typing. So it's like they just don't want to like type. And what they did, they changed is like instead of like having like just a chatbot, a box, they actually like suggested a few of like frequently asked questions about their situations. And then they realized that people like start clicking a lot more. And then they kind of try like, the user workflow. So I think it's a very interesting pattern that I've seen a lot as well. Cool. So I think that is a few of the common product questions. Like that's an example. But I see this like in every AI applications. I ask people like, what is the hardest part of building applications? And they will always like user experience, understanding what users want to do. So I think that a part that is both like scary and also very motivating. And the reason is that like I do think that because user experience is hard, is that why we still have jobs. Because if technology can just solve everything, then you don't really need human, right? If AI can just automate, can just throw everything into an AI and like have it do it for you, then why do we exist? Like, I'm sorry, I feel like understand what humans want and how users operate in the real world is a fundamentally like strength of like humans like operators. Cool. So the next one is like another anti-pattern is start too complex. Who here has a debate on which vector databases you use? Okay, I think people are like not very honest. So I do think this is like I'm not okay. So I know that some of my wonderful friends here work for like vector databases companies. I do think that's extremely important. I'm just saying that's like usually they are not like the first thing to get started with. So for example, like you're pretty familiar with like RAG application, right? Like retrieval augmented generations. So who here is familiar with RAG? Okay, now, thank you. I do think that is probably the most important like pattern of like AI application nowadays is retrieval, like to supplement AI with like relevant context because it does help you reduce hallucinations a lot. Because people have found out that like it's really hard for AI to figure out like what is the relevant context, and if you don't give it the right source, it can cite the wrong source and like hallucinate a lot more. So consistently providing right context, the right context really help reduce hallucinations and improve the response. Oh shoot, Mark is like, hurry up. Yeah, so I do think it's like, however, vector databases, like it's a fairly complex like system that you adapted. So I do usually think that people like typically start with like one like something simpler, like a term-based, that's like keyword, like retrieval. And another thing that's like, another thing that I really wish people would talk more about is data preparations for RAG system. So I do think that's like, because like, you hear pretty familiar with like chunking and like indexing, right? So like, for example, like you have a very long documentations. And let's say that the documentation is about optimized AI conference. And the document say like, from now on to the rest document, we refer to optimized AI as the conference, right? So you just chunk the document like that, and you just get the second chunk, and it never mentioned optimized AI anywhere. Then if you user ask about optimized AI, you might not get the right chunk for it. So like usually people try to supplement each of the chunk with like maybe the title or like the summaries or the keyword. So I think like Anthropic has a really cool article about like contextual retrieval. So like trying to provide each of the document like chunk with the right context so that the system can retrieve the relevant chunk for the applications. And also like another company, they told me that like, oh, it's extremely important to be able to format the document into Q&A answer like format, because like we given a query from users, you might try to find relevant questions, like, and then they can retrieve the answer. So they actually spend a lot of energy into like reformatting into like the format that AI can use. So I do think you need a lot of experimentations with finding the right format for the RAG, and I do hope that we will have more article on that. And of course, like using agentic framework too early. I think it's like we are getting more and more mature with agentic use cases. So I do think it's like I think it's like tools frameworks are very useful, but like using them too early can actually like hide away a lot of complexities that help you understand the system. And also like developer like makes mistakes, right? So like if you adapt a tool too early before you understand what you want to build, you might, like this framework might make mistakes, and so application might behave very weirdly and you don't understand why. Okay, so another one is going to be quick because we run out of time. Is like another anti-pattern is to forego human evaluations. Are we using AI judges yet? Who here? Okay, people are nodding. Good. I think it's extremely important because for a lot of use cases, that's the only way you could actually evaluate the system, right? But it's important to consider that AI judges are not just like one thing. Like it's an AI judge by itself is an AI applications, right? It's a system that consists of like the model, the prompt, and like the prompt you can instruct the model to do like different things like the scoring systems, criteria. You can ask the judge to like output score between 0 and 1, or like 0 and 5, 0 and 10, or like answer yes or no. And because of like it's an application, it means that it can change over time. So maybe like yesterday's a promise like this, and somebody found a typo, and they fix it the next day. So actually, the AI judge is or like you use a model by like some company, and then they update the model under the hood. So the judge itself can change, and this is a challenge because traditionally you want the judge to be like stationary, right? So if you know, so you want to be able to benchmark the application progress. If you knew that yesterday the accuracy is like 80%, and today's the accuracy is like 82%. You want to be able to trust that, oh, the application is doing better. But if the judge itself is changing, and you see that the application accuracy score is changing, you cannot tell like is my application getting better, or is the judge itself like has a change, right? So it's hard to trust that. So somebody call this like a criteria shift. And also like a pattern I see, like especially a bigger company, is a gap between like the team that creates those judges and the team that consumes those judges, right? Because like if you have like maybe like 20 applications and you all have the same criteria, like maybe like relevancy or like faithfulness, right? So you might have another team that's like take care of like building a judge for like faithfulness or a judge for like relevance, and then another team that's use a judge. And it's create like this like gap because if you don't understand how the judge is being built, you don't know how to evaluate it. And if the team like also changes the judge, you actually like flying blind. So it's actually very interesting of like questions of like who should own the creations of like AI judges. Okay, I think we can be quickly. Like you can see like, here's the example of some of the AI evaluation tool. And even though like they evaluate for the same criteria, which is faithfulness, you can see that they have entirely different different prompt and different scoring systems. Somebody had a yes, no. So like if you say, okay, I use this tool, I get the score of that. And if I use the other tool, I get the score of that. Then what does it even mean? So yeah, I think it's very important to supplement AI judges with human evaluations. So like you can do very something simple, like you can maybe like every day or like every week, like have a fixed number of like samples and have a human expert go through them. And it's very important to have very clear guideline because humans also make a lot of mistakes. So like it's important to have those to like correlate with the AI judges. Okay, I think for the last one, I just want to leave this one here. One of the biggest anti-pattern is that people over-index on early success. And they were like, okay, it took me just a weekend to build this wonderful demo. I'm sure I can get this on the market in like a week. It never happens. So I've seen like multiple times, like people like take like maybe a weekend to get to 80%, and then it take like forever to get there. But anyway, thank you so much, everyone. Here's just some of the anti-patterns. Oh, I want to leave with this. Maybe you can read it as well. Thank you so much.
Thank you so very much, Chip. Another round of applause for Chip.